Alright, this topic today we're going to talk about equilibrium over a rigid body, right? Basically what we want to be able to cover is identifying support reactions and relating them to free body diagrams. So if you look at the example that you have on the slides, you'll see a platform suspended from an oil rig. And then the question is, how do you figure out what the support reactions are? So the first thing, as we always say, is that we start with the free body diagram, right? And in this whole platform can be simplified into a few different points, right? You have the point A, and at A you have AX and AY. You also have a cable, so you have a tension along the cable, right? And then the object or the platform itself would have some weights G, or we like to call weight W, right? So how would you solve for this? You would use some of the forces as well as some of the moments. Some of the things that you should see right away are, well, let's look at it in a different light. You have, just redraw that all of a sudden. You have AY, AX again. You also have the tension, and you have G. Right here you have some distance that you could use. We call that X, and then, as we always say, you'd have some distance right there, right? So we call that D. If you sum the moments, you'd have the tension times D. Oop, let me write that a little bit clearer. Would be equal to the weight times X, right? That's if you sum the moments about the point A. And remember that when you sum the moments about point A and you have these two forces acting up, you don't include that in your moment calculations, right? So that way you could calculate what T is in terms of D. Once you have the tension, you have the weight, you can then use these to calculate. You have a theta right here, you can use these to calculate what your forces are in terms of T and G, right? And just what would we have here? T sine or cosine? Which one would it be? I think what we'd be looking at is T cosine theta, right? Would give you the Tx value, and T sine theta would give you Ty value, correct? And then you'd have, these would be all knowns, and then you could just sum the forces in the X and the sum of forces in the Y, and you should have that problem. So the steps, as always: one, free body, simplify, you sum the moments, you sum the forces, right?